In this orthokeratology case, the patient's worn lenses for a few months now, but is still a little bit undercorrected. If we look at the posterior topography, the treatment zone or the edge of the treatment zone is a little bit better formed than when we previously visited the case, but in the periphery we can still see that the lens is fitting pretty loose. Here's the lens that the patient's wearing right now. Last time we made the lens a little bit bigger and we increased the demand. So it's a pretty flat lens at this point for a minus 350 sphere power. I don't think we need to necessarily increase topo demand a whole lot more. What I would try to do is just get this lens to seal off a little bit better in the periphery to see if that'll get the push-pull effect to be more effective centrally. So here at the blue dot, we'll just click down and bump the central clearance up a little bit. So this will give us more bearing at the back edge of the treatment zone. Now in this case, we don't want to mold out all the cylinder because we got about a diopter of internal cylinder, but thus far we really haven't been able to mold out any. So I don't think it's a bad idea to try to get rid of some of this corneal cylinder. And how I would do it in this case is to just go to 50% mode and steepen the vertical meridian of this lens. So same thing, we're just going to make the periphery steeper, but we're only doing it in the superior and inferior quadrants. Freeform lens, so we have to do the same thing in both the superior and inferior quadrant. One last thing we can do, we want to keep a thin edge so that the lens is less likely to move around, but we can increase the center thickness for a little bit more central push. So now we have a lens that looks like it's not going to fit very well, but for the purposes of troubleshooting this case, I think this will help get us a little bit closer to refractive target. So hopefully this is helpful. Best of luck with your patient, and thanks for watching.